today on the syllabus is using graphs. Sketching graphs is what I've said. So I'm going to start off just by looking at how to sketch linear graphs on I'll say paper, but obviously I'll be doing it on the computer screen here. And then later I'll get into using Excel for drawing graphs, and that's one of the things that Becky's asked us to do. And I'll go into that in a bit more detail. Okay, so let me get, and I forgot to open it, so give me a second. I want the whiteboard. Are we there? Yes, we are. Okay, and we'll have a whiteboard. So imagine we've got an equation of the sort, which is y is equal to x plus 3, which is a straight line graph that hits the axis at 3. So this is a very simple example, but if I had to sketch a graph, what I would tend to do is to start with a table. Let me do that again, because what I'd really like to do is have x on the top and y on the bottom. I draw myself a table. It's meant to be horizontal, sorry about that. And I'd sort of start over here with x equal to 0. So I've got space for some negative values and space for some positive values. And then I'd populate the table with what those values are. But in the case of a straight line graph, what I might be tempted to do is just take 2 points, because 2 points will give you a straight line. So when x is equal to 0, looking at the equation, when that is 0, y is obviously going to be equal to 3. Okay, and then the other thing I'd like to look at is when y is equal to 0, so when that's 0, x is going to equal minus 3, isn't it? Okay, so when y equals 0, I move the 3 across to the other side, so then it becomes minus 3. So I need some axes, which are like so, and when x is 0, y is 3. So when x is 0, y is 3. I was doing it in red, wasn't I? When x is 0, y is 3. And when y is 0, which is obviously the x-axis, x is equal to minus 3. Okay, so now if I call up the ruler and I rotate it like so, it's about 45, is it? Yeah, that's about right. And then I can draw the line like so. Okay, so very simple graph. It's got a positive gradient, which means it's going sort of uphill from left to right, and it's passing through x is 0, y is 3, and y is 0, x is minus 3. Okay, it's very simple. I'd need 2 points and I've got a graph. But if this were a quadratic or a cubic, then obviously I'd put more numbers into the equation here. So why don't we do that? Why don't we plot y is equal to 2x squared minus 3x plus 4. Okay, so this time I'm going to put an x and a y into a table. I'll put my initial value in here. When x is 0, y is going to be equal to 4. When x equals 1, and just go for easy numbers, this is going to be 2, this is minus 3, so that makes it minus 1. And then plus 4 is going to give us 3. So y is 3. Let me just check that. So that's going to be 2 minus 3, which is minus 1, plus 4 is... Right, so when x is 0, y is 4. When x is 1, y is 3. So let's do x is 2 whilst we're here. Okay, so 2 squared is 4, times 2 is 8, minus 6, so that gives me 2, and plus 4 is going to be 6, okay? And now let's do minus 1, just to see what's happening on the other side of the axis. So minus 1 squared is 1, so that's going to be 2. This is going to be minus 1 times 3 is minus 3, but we've got another minus, so that's plus 3. So that's 2 plus 3 is 5, plus 4 is 9. So when x is equal to minus 1, it's going to be 9. Now let's just look at the numbers we've got here. We've got y is 9, then 4, then 3, then 6. So we've gone from a number, we've gone down again, and now we've gone up, which means we've passed the turning point of the graph. So let's just draw that. We've got minus 1, 1, and 2, and we'll put the numbers in. So when x is equal to minus 1, y is 9. When x is equal to 0, y is 4. When x is equal to 1, y is 3. And when x is equal to 2, y is 6, which is going to be about there. So we're going to get a curve that looks something like that. Okay, I've not quite got the data points. So what we've got is a curve, and these quadratics are always symmetric, so the minimum point is going to be about here somewhere. From going off in that direction, we know what's going to happen there. Going off in that direction, we know what's going to happen there, by which I mean x is going to go to infinity and y is going to go to plus infinity. Here x is going to go to minus infinity and y is going to go to plus infinity. So in terms of what the curve is doing, we're not really that interested in the two tails of the curve. We're interested in any point at which it crosses the x-axis, which are the roots of the curve, and we're interested in the turning point, because obviously that's where the data is of interest. So if you have to sketch a graph in an exam, particularly if it's something more than a straight line graph, obviously with a straight line graph you can quite quickly do a sketch without even bothering with a table. But if it is a non-linear graph, I would expect you to do a quick table and then do a quick sketch of the sort that I've done here. Now, what I'd like to do next is to get some data and see how we would do this in Excel. If I can minimize that and then pull up some data. Now, what I did this morning is I went onto the government's data.gov.uk to get some data, and you can see the data here is just how it's come into it. I've saved it as an XLS file. It actually comes in as a CSV file. So if you double click on these boundaries here, you will see it expands to show you the data that you've got there. So this is new cases by specimen date, and this is cumulative cases by specimen date. So this is data. It's a lot of numbers, which is something that you might well collect in an experiment or something like that. But if I mark the date column, I've just clicked on that column, and I'm going to click on the new cases column. I've now identified two columns. Now if I go into insert charts and then I want a scatter graph, if I put that graph in there, I've now got a graph of new specimens by date. Okay, so it's taken the first column that I had identified as the x-axis, and it's taken the second column that I identified as the y-axis. So that's what we've got here. We've got date along the x-axis and we've got the number of cases along the y-axis. Okay, and the key thing here is that I didn't sort of specify which was which. I just identified the columns and it drew the graph for me. And now I've got the graph. I've got all these different ways of formatting the graph depending what I'm looking for. And what this is telling me is that I've taken data here, and from the data I'm actually extracting information, aren't I? I'm getting an idea of whether cases are going up or down, or what the trend is. Now the next thing I want to do, maybe I'm interested in the cumulative data. These are the actual cases per day, but if I'm interested in the cumulative data against date, so what I would do in that case is I would mark the date column, then I'd press the control button and mark the cumulative cases. So you see now this column and this column are the ones that are shaded in. So now when I go insert charts graph, this now draws me a graph to show me the cumulative cases in the UK. And let's make that a little bit larger so it's about the same size as the other one. Okay, and then I've got cumulative cases. So that means I've got two graphs on separate charts, obviously, both using the same date, which is the x-axis, because I use the same column in the data that I got here, and then the data that's displayed is new cases per day and cumulative cases per day. Okay, so, and that's showing us how many data points we've got there. Okay, so that is taking a large amount of data from a data source, which could actually be experiments that you do in physics or mechanical engineering or whatever you're doing, chemical engineering, and then plotting the data that you've got from there with very few commands. I mean, I didn't have to do much to get these graphs. And I don't know about anybody else, but for me, a picture does represent 1,000 words. Okay, so let's park that. Now what I'd like to do is to graph the two things that I did manually, just so we can see how they would work. So I'm going to make a model of a straight line. So y is equal to mx plus c. So I'm going to put a field for m and a field for c. Right, so I will now mark everything and put my data in the center because I think it looks tidier that way. Right, so for the gradient I'm going to put 1, and for the intercept I'm going to put 3. This is the first line I drew before. And now I'm going to make a table of x and y values. So the x value, let me move those down a little bit. So I'm going to have x0, which is where my start value. And at the moment I'll make that 0, I suppose. And I'm going to put x dx, which is my change in x, and I'm going to make that 1. So now here I'm going to say that the first x value is equal to, so I press the equal symbol, that's equal to that cell there. And when I press enter, that's the value that's in there. Now I'm going to say this field, let me make it a bit larger so you can see what I'm doing. This field here is going to equal the previous cell, click, plus the change in x that I'm asking for. And I need to put $1 in front of the 6 to make that a constant, so it doesn't change the 6 as I copy this down. Now the y value is equal to, it's going to be m, which is this value here, times x, which is this value here, plus c, which is this value here. Now the numbers with 4 in them are the m and the c, and they need to be constant, so I need $1 in front of both of the 4 values. Okay, so that's mx plus c is what's in there. And now if I copy that down, there we go, x is 4, and now I don't need too many of these values, so I don't know, take it down to about 21, so I've got 10 values, and something's gone wrong. So let's just see what's happened here. Yeah, okay, I seem to have copied that funnily. I don't quite get what happened there, but there we go, that's the graph. And now, as before, if I just block mark both of those and say insert scatter graph like that, and now I've got the graph. So if I just zoom out a little bit so we can see what the data that I put at the top here. So the gradient is 1. If I now change the gradient to 2, the graph has changed, and what you'll see is that the numbers here go higher because Excel dynamically rescales the graph. So if I change the gradient is here, to say -2, you'll see that the graph now has changed and it's a negative gradient. And if I put the intercept here is 3, so if I make it 10, shall we say, so you can see where it's coming through, there it is coming through at 10. I said my first x point is 0, so let's go for -5 so we can see it. We can see both axes, so there's the y-axis and there's the x-axis across there. So now instead of having the graph of a straight line, I've got the graph of all straight lines. Now let's just extend this a little bit. So instead of m and c, I'm going to call that m1, and I'm going to call this one c1. Okay, so now what I'm going to do is I'm going to have an m2 and a c2 for a second graph. So I'm going to put a value here of, I don't know, 3, and the intercept will be 5, just as some numbers. I'm going to call this one y1, and I'm going to call this cell, I need to move my graph a little bit, I'm going to call this cell y2, which is the second line that I'm looking at, and that first cell is going to equal, it's mx plus c, remember, so it's the gradient, so that is equal to the gradient times the x value plus the intercept. Okay, and again we've got to put dollars in where the 4s are, so we put $1 in there, and a dollar in there. Okay, and now I'm going to copy that down to 21 like the other one. Okay, so that's my second graph. So now what I'd like to do is I'd like to add this second graph to the chart. So what I'm going to do is I'm going to right click on the line and then select data. So I've selected the data and I'm going to add a series. I won't bother giving it a name, so Excel will call it series 2. And it says, what are the X values? Well, here are the X values from A10 down to A21. And then the Y values, so C10 down to C21. What's it doing? Okay, so we'll accept that and we'll accept that. So now I've got both of the graphs on the single chart. And if I were to change this to -2, then I'll have two parallel lines, okay, intercepting at 5 and 10. But if I make this, I don't know, 1, let's say, you can see that I've got a point of intersection. Now let's just think about what's happening here. We've got one graph which is y is equal to -2 plus 10. So this is y is equal to -2x plus 10, and -2x plus 10 is true for every point along this line. Okay, so everywhere along this line y is equal to -2x plus 10. Now the yellow line, the equation of that is y is equal to 1 times x, so y is equal to x plus 5. So everywhere along that line y is equal to x plus 5. And at this point here, and uniquely in the universe at this point here, both of those statements are true. So at this point and at no other point, it's simultaneously true that y is equal to -2x plus 10 and y is equal to x plus 5, which means that we've found a point of simultaneity. We've got two simultaneous equations. Now that point there is just a little bit less than 2, isn't it? So if I look on my graph here, I've got at x equals 2, the first line y is equal to 6 and the second line is y is equal to 7, and that's the closest point. But I can zoom in a little bit here. So instead of starting at -5, let's say I start at, I don't know, 1.5, shall we say? And instead of having a step of 1, I have a step of, I don't know, 0.1. Okay, so I've now zoomed in quite a bit on this graph, and I've got a point somewhere here. Okay, so the point of intersection is halfway between 1.6 and 1.7. So let's start at, we're at 1.5, so why don't I put 0.05? So I've drilled down a little bit closer, and the intersection here is between 1.65 and 1.7. It's between those 2 points there, isn't it? Okay, so that might be close enough for a solution without me having to do simultaneous equations. Now I know these are straight lines and it would be trivial to do them as simultaneous equations, but if these were more complicated lines, logarithmic lines for instance, or quadratics, it could be 2 quadratics, you can quite quickly generate a graph and find the points of intersection, which is what I'd like to do next. How are we doing for time? We're all right. So let's take, let's have a new sheet. So what I'm going to do now is to graph a quadratic. So I'm going to have an A and a B and a C, and I'd like those values. Let me zoom in a bit so we can see the values. I'm going to have x squared minus 2x minus 1, so it's going to be x squared minus 2x minus 1. Okay, so that's my quadratic, and then I'm going to have here M and C, which is going to be my straight line, which is going to be -3/2, so -3, so equals -3 divided by 2. So I'm putting it in as an equation, but Excel will calculate that for me, and I'm going to have +6 for the intersection. Right, so now I'm going to have my x column, Then I'm going to have my y1 column and a y2 column. So the x value is going to, I need an x start and an x and a dx. So x0 is going to equal, and I'll put 0 in there to start with, and I'll put dx, which is my change in x, which is going to be in there, and I'll put that as 1 for now. Right, so if I go across to here, the first value is going to equal this value here. The second value is going to equal the previous value plus the change, and I need the dollar in there, so I'll put that in there, dollar. Right, now this equation I'm going to use the nested form, so I'm going to say this is the quadratic, so that's going to equal, and because it's how you do nested forms is you take the highest order and you need one fewer brackets than that. So a quadratic is obviously x squared, so I just need one bracket, so it's going to be a times x plus b, close the brackets, times x, which was a6, plus c, which is that value there. And now all these line 3's need dollars in front of them to make them constant, so we'll put a dollar there, a dollar there, and a dollar there. Okay, and if I copy that down, that should change our value, which it has done, so that's looking all right. And then we'll put in the straight line whilst we're here, so we're going to say that that is equal to, and it's going to be m times x plus c. Okay, and I need dollars in front of the 3's again, so there's a dollar there and a dollar there. Put that in, and that's the value 6, and I need to copy that down as well, so I'll copy that there. Now, because the x value here is just a single value from this cell here, that doesn't have the incremental counter which this one does, which is why I put the second line in. So now when I copy that, we're on 6 there, so let's take this down to, I don't know, 26, shall we say. That should do it. So 26, right, and you can see all of our points get recalculated. So now if I pick up all of the data of the quadratic and then insert a graph like so. Okay, there's my quadratic, so let's just move up the page a bit. Come on mouse, where are you? And make that a bit bigger as we have the space. Right, and now what I'd like to do is to add the straight line to that, so I'm going to right click that, I'm going to select data, I'm going to add a new series, and the series x values are going to be from A6 down to A26, so that's my x values, and my y values, so from C6 down to C26. Okay, so that's okay, and okay to that. Right, so now I've got my graph, but what I'm actually interested in are the points of intersection. I can see there's one point of intersection here, but the other one is to the left here. So instead of starting at 0, why don't I start at something like -4? There we are, and I could actually go a bit further than that. No, I think I'll leave it at -4, but instead of having a step size of 1, I'm going to use a step size of 0.5. Okay, and that's looking better. So at around a bit less than -2, I've got a point of intersection there. So -2 is there, -2.5, that's -2.5, and those values are quite close. They're closer than -3 and they're closer than -2. So I could drill down a bit further. So what about 0.1? Will that actually give me the point of intersection? So that's at -2.5. So it's around here somewhere, and if I make that 0.2, I should say, oh no, 0.3 then, 0.3. So the point is, okay, 0.5 then. The point is I can see where these two points of intersection are, and that one looks to me to be about 3. Okay, it's not quite 3. it's 2.5-ish, so that's about the point of intersection. So without calculating this algebraically, I can quickly get an estimate of where the intersection points are. What I'd like to do now is to look at what this would be like as an example on paper. So I'm going to clear this, clear the canvas, and I'm going to take one of the examples from the textbook. We're going to graph y is equal to 2x plus 3. Okay, so when x equals 0, y is equal to 3, and when y equals 0, and y equals 0, 2x equals minus 3, so x is equal to minus 3 over 2. So if I were to graph that, when x is 0, y is 3, so I'm going to get a point up here somewhere, and when y is 0, x is equal to minus 3 over 2, so that's going to be, I don't know, somewhere like that. And then I can put a ruler on. How close am I? Okay, that's not so bad. And that's what the graph should look like. Okay, now the next thing is to find the point of intersection. So let's move that up a bit. So we want the point of intersection between y is equal to 3x minus 1 and 4y is equal to minus x plus 22. Okay, so for the first line we're going to say that when x equals 0, y equals minus 1, and when y is equal to 0, x is equal to a third. So when y equals 0, 3x equals 1, so x equals a third. So, and then for line 2, when x equals 0, y is equal to, so when x is equal to 0, 4y is equal to 22, so 2y is equal to 11, so y is equal to 11 over 2. Alright, and then when y equals 0, x is going to equal 22. So y equals 0, so that goes away, so minus x plus 22 equals 0, so x is equal to 22. Right, so what I now want to do is to graph that. So again, I say graph it, I mean sketch it, which means it's just a quick sketch like that. So doing the first one, when x equals 0, y equals minus 1, so I guess I better put some little lines on. X is going to 22, so I'm going to do 5, 10, 15, 20, 5, 10, 15, 20. And my y values aren't so huge, are they? That's 6, so I'll say 2, 4, 6, 2, 4, 6. So 2, 4, 6, 5, 10, 15, 20. Okay, so let's put those on. So when x is 0, y is equal to minus 1. So that's going to be about there then, isn't it? And when y is 0, x is equal to a third. So that's going to be about there. So let's put that line on there. Right, and I'll put that line in. And then we'll do this second one. So when x is 0, I'll do this in green. So when x is 0, y is 5.5. So x is 0, y is 5.5. So that's going to be about there. And when y is 0, x is equal to 22, which is going to be about here, isn't it? Okay, so let's draw that line in. there. Okay, so right, what we've got then is an intersection point. I'm going to make a guess here. I'm going to say that graphically the intersection is I don't know, about 8, 4. So it's going to be 8 in the x and 4 in the y. Okay, so that's my guess from the graph. So that's there. So let's do this algebraically. So if I just take that equation, let's move the page up a bit. So it's y is equal to 3x minus 1. So y equals 3x minus 1. And the other one was 4y is equal to minus x plus 22. I'll call that equation 1 and that equation 2. So if I do equation 1, let's put brackets around so you know that that's an equation number. So equation 1 times 4, we're going to get 4y is equal to 12x minus 4. Okay, so now what I'm going to do is I'll call that equation 3, and I'm going to subtract 2 from 3. Okay, so that gives me 4y is equal to 12x minus 4, and then I'm subtracting 4y is equal to minus x plus 22. So I'm basically subtracting these, so 4y minus 4y is going to give me 0. 12x minus minus x is going to give me 11x. Just be careful with that. So it's 12x minus minus x. So I've got it wrong, how funny. 12x minus minus x means that it's not subtracting, it's adding. So excuse me on that one, Control Z, Z, Z. So it's 12x minus minus x is 13x. And then we've got minus 4 minus 22, so that's going to be minus 26. Okay, so that means I can now write that 13x is equal to 26, so x is equal to 2, so 2 13s are 26. Right, now I'm going to pop those back into the equations 1 and 2. Oh, come back. I want to go down. So in equation 1, let me put it on the side here. In equation 1, if I put x equals 2 in there, so 2 times 3 is 6, minus 1 is 5, so y is equal to 5 when x equals 2. And then sanity check. When sanity check, so in equation 2, which is this one here, 4y is equal to minus 2 plus 22. So 4y is going to equal 20, so y is going to equal 5. Okay, and then the key thing is that y equals 5 there, y equals 5 there. So I can be confident that I've got my values right. So the actual values are x is equal to 2 and y is equal to 5, which is not quite what we got from the graph, but then it was a sketch. I've lost my mouse. So x equals 2 and y equals 5 rather than 8 and 4. Okay. Right, I think that's enough on sketching graphs. So just to review, we've sketched graphs on paper, or on a whiteboard, and we've also sketched graphs in Excel. So we've got ways of doing both of them. We've used linear graphs, but there's no restriction on that. We can use whatever kind of equation we want to use. So now we can actually get a handle on a solution without solving it algebraically. So if you run into an equation at some point in your life that you can't solve algebraically, you can always graph it to get some idea of where the solution lies. Okay, so unless there are any questions, I think it's time for breakout rooms.